This section of the Electrical Project Inspector Overview class is going to address site and underground electrical systems. Whenever a project inspector is inspecting site electrical construction, there is certainly a possibility that there may be a requirement to review some of the information that has been provided in the plans and the specifications with the California Electrical Code. Some of those references that may be useful to review are the following. Minimum cover requirements. The information will be found in California Electrical Code Article 300.5A and Table 300.5, titled Minimum Cover Requirements, 0 to 1,000 volts nominal, burial in millimeters and inches. Another reference would be Article 110.3, which addresses listings and raceway types. Article 300.5D3 addresses warning ribbon, which is generally placed and required whenever there are service conductors. And the requirement would be that the warning ribbon is placed 12 inches minimum over service conductors. Article 352.24 addresses bends and the fact that they cannot damage or reduce the internal diameter of a conduit. Chapter 9, Table 2, deals with proper radius of bends, including field bends, and we see field bends quite often on construction projects for underground conduit installations where the conduits are fairly sizable. Article 352.26 addresses the requirement for a maximum of 360 degrees in all bends between the pull points. So these are all very common references that a project inspector would find helpful to review during site electrical work. When the inspector is reviewing any site electrical installations, it's very important that they remain aware of any differences between the California Electrical Code, the project specifications, and any utility requirements that are enforced in the locality where the project is being constructed. The specifications may indeed be more restrictive than information provided in the blueprints or the plans. Utility requirements may also be more restrictive than the specifications. For instance, the California Electrical Code requires a minimum cover of 24 inches. But typically, again, dependent on the geographic location, the utility company may require more cover as a minimum. For instance, SMUD has a minimum requirement for 30 inches of cover. Additionally, concrete encasement of site conductors may be required. And this would be specified generally in the specifications. It also may be indicated on the blueprints. It's important to look for construction requirements for concrete duct banks, including the number of bends permitted in one run, and metallic raceway requirements, metallic being either RMC, IMC, or PVC coated raceways. Now we'd like to take a few minutes to discuss plan reading, specifically for electrical systems installations. And I'd like to start by sharing a very simple statement that I'd like every project inspector to take near and dear to your heart and make it part of your everyday processes. And that is, read and review every word and every symbol on every plan sheet and every specification sheet for every project always. This may seem very obvious to some view inspectors. However, I'm just sharing this because I know in my own experience I had become complacent on some jobs and had started assuming that some things that I had read for similar projects applied to all similar projects, and unfortunately was embarrassed to find out that I was wrong. So the importance of making sure that you read all of the information that has been provided by the design professionals and approved by the appropriate individuals is paramount. To recap, plans are basically just a drawn guideline or description for construction, and the plans and this drawn guideline also include helpful written clarifications. The plan basically creates many pictures of what you would expect to see constructed, and most of us as construction people are very visually oriented, and it's extremely helpful to look at these pictures and form pictures in our minds of what we'd expect to see. These pictures include big pictures, which are site plans, plan views, and exterior elevations, to name a few. These give us a large view or an upper level view of what we would expect to see constructed. Smaller pictures are pictures such as cross sections or cuts, interior elevations, and also details. And these obviously give us a little bit more detailed information about specific smaller areas of the bigger picture. The words that are associated with the pictures are also equally important, and they provide us much more detailed information about specifics for each of the components, some of the processes and materials that are going to be constructed, as well as sometimes methods for construction. So the words are also very important as the drawn descriptions. Continuing with discussing importances in the plans and the words combined provide essential inspection information. With respect to electrical systems, they provide information relating to raceways, such as conduit sizes, types, and any specialties associated with the raceways themselves. They also provide information specific to conductors, such as the numbers of conductors, the sizes of the conductors, the types of conductors, as well as the function of the conductors. Panels, equipment, and components are also identified in more detail in the plans, such as the types of panels, equipment, and components, brands, the parameters, the operating parameters of these particular items, where they are located, what their function is, how they are required to be identified, including any signage that's important for each of the panels, equipment, or miscellaneous components. The plans will also identify routing recommendations or other options for routing the conductors, such as utilizing new trenching or using existing crawl spaces or tunnels. Work responsibilities are also identified, such as what is the contractor's responsibility, what is the owner's responsibility, and does the utility company also have a responsibility for constructing portions of the project. The scope of work is also clarified in the plans and the words associated with those plan drawings, such as what is new construction, what is existing construction, is there future construction, and is some of the construction temporary in nature and will be removed after the project is sold. This slide shows a drawing of a typical site plan view for an electrical installation. And as you can see, there are a lot of notes, a lot of words associated with a lot of pointers that are shown, which identify any number of items that we just discussed on the previous slide. So this is basically the big picture, the site plan view of a task or a group of tasks that are required to be completed for the project. And again, it's very important to read every single word and every symbol on this page to get a very clear understanding about the big picture. This particular slide shows just a small section of the previous slide we were just looking at. And this follows the same thought process to looking at the big picture and then drilling down into smaller pictures. Now this particular image is taken from the previous one, so it's just a smaller portion of a bigger picture. But it also shows specific information relating to how the actual emergency generator is going to be fed from an existing substation. So all of the words and all of the symbols on this page are basically showing more detailed information about how to get the conduit or the raceway and the conductors from the existing substation to the new panel located next to the restroom, and also from there to the emergency generator. So it's extremely important to be very logical with your approach to looking at the big pictures and drilling down into the smaller topics or the smaller pictures. Also, it's important to note that any notes that are associated, any sheet notes that are included on any of the plan sheets, that you take the time to read every single sheet note. And if you need to, many times these sheet notes are numbered and they correspond to numbers on the drawings themselves. It's extremely helpful at times to use colored pencils or highlighters, etc., to distinguish on the drawings themselves what the sheet notes are that pertain to each of those details. For the simple fact that if you make this a regular part of your daily routine, you will become a better project inspector immediately. I guarantee it. This slide also expresses the standard drill down feature that all plan reviewers or all plan users will use. This is an even smaller look at the previous sketch or drawing, which shows some details specific to the diesel generator that's going to be installed. So again, read and review every plan and specification sheet for every project every time. This slide shows a photograph of a contractor preparing to concrete encase some service conductors. And as you can see by the photograph, it looks like this contractor's definitely a professional. The trench itself is very neatly excavated. The base that the chairs that are separating and suspending the conduits is nice and tight and flat. It looks very hard packed and secure. And it's extremely important to prepare in this type of manner for any type of concrete encasement of conduits, because the last thing that you want when you're actually placing concrete on top of conduits is for any of the conduits to become displaced or separated in any way. Article 300.5F addresses backfilling, but we thought it appropriate to show this type of slide, even though it's associated with concrete encasement. The main point is that it's very important to prevent damage to any raceways. A new amendment to the California Electrical Code is Article 300.5G, a section in that existing article where the California Electrical Code now requires the sealing of all spare or unused raceways for underground installations. As we stated before, Article 300.5F addresses underground backfilling and also associated tasks with ensuring that conduits that are installed as site work are done so properly. And one of the main considerations during this process is to protect the conduits to make sure that they are not displaced and they are not damaged. It's important that clean fill is used when plastic conduits are being used to make sure that no point loads are being impressed on the conduits themselves, which would have a tendency to maybe reduce the interior diameter of the conduits or the raceways. So large rocks, paving materials, cinders, and the like are not permitted for any backfill material. Additionally, warning ribbon is not always required. However, if the contractor is installing service conductors, then according to Article 300.5D3, warning ribbon is required a minimum of 12 inches above the service conductors. Now we're going to talk a little bit about factory or field bends for conduits that are installed. The California Electrical Code does permit field bending of conduits, and Article 352.24 addresses that. However, it's important to remember that the specifications may not permit field bending of conduit. So it's very important that the project inspector reviews the specification requirements for the installation of field bends. Review for conduit conflicts with any structural components, such as footings or grade beams. Understand also that the permitted bend radii are listed in California Electrical Code Chapter 9, Table 2, and these will pertain specifically to field bends that are made by the contractor on site. Now, if you look at this picture, you can see that there's probably some issues worth addressing with some of the conduits that are installed. You can definitely see that at least one of the conduits have been field bent and actually has a kink in it. As you can see right here in this area, this second conduit from the right has got a noticeable kink in it. And as you look further left, you can actually sort of perceive that these next two conduits, or even three or maybe four, also are bent to the point where they're not yet kinked, but it appears that the interior diameter has been reduced by bending these conduits too tight. So again, it's extremely important that whenever field bends are being made to conduits, that the project inspector pays very careful attention in a timely manner to whether or not the field bends are acceptable or will pose a problem. It's common that whenever electrical site installations are performed, that you would expect to see some pull boxes or some vaults that are enclosing electrical conductors or other components. It's very important and required per California Electrical Code Article 314.30 that these types of electrical boxes are marked. Generally, we'll see them marked very simply as electric, but you may also see other markings such as communication, etc., low voltage, any number of things. The cover has got to require a tool to open, and the reason for this is you don't want anybody just opening these particular vaults or boxes because of the electrical shock hazard that is contained within them. Also, If the covers are in fact metal, as you can see in this picture depicted, all the metal parts have got to be bonded. And as you can see, there is a green bonding wire that is jumpered to the green ground wires within this particular handhold. This picture on the right clearly shows one of the very common nightmares that are associated with large projects, specifically all of the electrical that no one sees. Again, electrical systems installations are very heavily dependent on routing considerations. And as you can see from the picture on the right, there are a number of panel boxes that are installed in this area. And I would presume that this is probably the electrical room or one of many electrical rooms, due to the fact that it appears that there's a tremendous amount of conduit. And again, I would presume these are generally home runs from other panels focusing on this one area. It's very important that conduit layout for proper panel board clearances are considered, and the reasons are obvious. You can see by looking at this picture, if the electrical contractor is not careful, it would not be unheard of that they could stack 4 or 5 conduits deep in some of these areas. It's also important to be up on what the conduit sizes and the types of conduits that are being used in these areas are as they're being installed. What you definitely don't want to do is you don't want to be complacent and then come back after the fact and have to embarrassingly remind the contractor that a 1-inch conduit that he's installed in the bottom of this mess is supposed to be 1.5 inches or 2-inch. Remember that conduits they have to be located under the slab on grade and the moisture barrier. So all of these conduits that we can see in this picture are going to be covered with sand cushion and also the moisture barrier. So it's unfortunate that there's a lot of hard work that is never seen by anyone, but it also impresses the importance of making sure that whatever is done here is correct. That would certainly save any type of unsightly surface-mounted conduit, which should always stick out like a red flag for anyone on a new building. Another important consideration is identified again, and this is a repeat of a previous note that we've had in Article 352.26, that the code requires a maximum of 360 degrees in bends between pole points. And this is a good opportunity to address an issue regarding using the actual California electrical code in conjunction with the blueprints. DSA continues to stress that project inspectors must inspect construction, all construction, based upon the DSA approved plans and also the DSA accepted plans. When I say accepted, I mean plans that do not address structural, fire life safety, or access compliance issues. And as we know, electrical certainly falls into this area, with the exception of bracing, hanging, or supports for electrical components or equipment. So this Article 352.26 is an extremely important article that all project inspectors have been aware of since the very inception of their tenure as an inspector. This is one of the most common code requirements that there is. However, it would not be surprising that this code requirement is never mentioned in a set of DSA approved or DSA accepted plans. So again, it's extremely important to understand that a project inspector is going to have to be also referencing the California Electrical Code to ensure compliance with the DSA approved or DSA accepted plans and specifications.